Hi and welcome. My name is Pasaka Itabe, and as you may not know, my channel Autumn Green is all about taking your makeup projects to a whole new level. And in this episode, basically, I'm going to be teaching you guys how to integrate motion sensing into your projects. It's a bit cold out here. In fact, it's very cold in the Free State. So I thought I would build a project that would help me deal with it, right? And I mean, the cold front is approaching this weekend, so it's about to get even colder. So I thought, hey, let me make a project that can help me out with that. And the project I'm talking about is the one here right behind me. As you can see, I've integrated a motion sensor into it. And so what happens basically is that every time that I enter the room and I'm in close proximity, my heater will go on, and when I'm out, it will actually switch off, right? And there's a very low wattage heater. I think it's about 400 watts. So yeah, it's rather comfortable to use, and I've made some modifications. And in this video, I'm going to include a lot of resources that you guys can get your hands on if you want to do it for yourself, maybe as a weekend project. So otherwise, let's get into it. Thank you. Yeah, so guys, this is what I'm gonna be working with. There's a panel as I found it. As you can see, it's pretty messed up. It has cracked and broken in the corner. But all we're gonna go and do is actually fix this. And the way we're gonna do that, we're gonna start off by grinding these parts before we put them back together. Guys, do wear a mask when you do this because I'm not sure if this is some composite or asbestos. So I'd rather be safe. So I'm just wearing a mask, wearing glasses. I'm gonna grind this down. I'm gonna do both sides, and I'm gonna be grinding the panel as well. Uh, these parts that I'm grinding away basically gives me enough room to fill the gap using some filling powder and reinforcing glue, as you will see. So I'm gonna go ahead and do the panel as well. Make sure to eat away at the edges, because if we just go ahead and put it together without doing this, you're not gonna have much room for reinforcing the whole panel. So uh, this is gonna take it's not the nicest thing to do. You're not gonna enjoy it, but you have to do it. And so now that I have it, I'm fitting it, and yeah, it fits quite well. So what you then need to do is to just take these two parts and then clamp them together. Guys, remember that you have to wear a mask if you're working with this, because I think it's asbestos or something. So you don't want to inhale this stuff, eh? So when you clamp them down, make sure that they're straight, uh, and clamp them down tightly, but don't tighten them so much that they actually actually crack. This is a fragile material, so you want to hold it down tight but not too tight. uh, and again, you don't want to leave a dent there because you still need to paint this whole thing. So I'm just going to clamp down both sides and make sure that it's not moving. And now that we have it clamped, what I'm going to start with is the filling material. It's actually what they call it is reinforcing powder, filling powder for short. Okay, it's actually filling and reinforcing powder. I'm using the gray type. This one is for aluminium, metal surfaces, and gray plastic surfaces. But anyway, I'm gonna go ahead and use it for this. So once I'm done, I'm gonna point the reinforcing glue, and then it makes it a solid substance. I'm gonna do the same for the other side. Pour it, flatten it down, and you can use this stuff for pretty much, I want to say almost anything. It's quite durable. It's quite tough. Uh, so there you go, and it sets almost immediately. Uh, So as you can see, at this stage I can even remove the clamps, but I would rather be safe. So I'm gonna do the same for the other side, fill in the powder, flatten it down, and then pour in the glue. This is how it's actually recommended that you use it. You know, do the same for the other side, and don't put in so much glue that it actually overflows. You just want enough for it to bond, and make that sort of solid substance here. As you can see, it's even smoking right there, and you can see it's dry to the touch immediately. So I'm just gonna go ahead and unclamp these two, and just use a grinder to actually just flatten it out before I actually paint it. That looks solid, and yeah, it is ready. What I'm gonna do next is I'm gonna take a piece of wood, and I'm gonna put it across the length of the panel. uh, and what I'm gonna do is just mark it and cut it. I don't want to make it too complex and whatnot. Just take a pen, hold down the piece of wood, and then just mark off where you want to cut it. Make sure it's the same length as the whole panel. And once I'm done with it, I'm just gonna go ahead and cut this piece of wood. Yeah, don't judge me for my instrument. Yes, if it can cut, hey, just use it. Even if it's a hacksaw, just go ahead and use it for wood. I just want to get the whole job done, so I'm gonna go ahead and do that with my superhuman speed. As you will see, like, I am that good at it. Look at that. Woo! And yeah, I am done. It's looking nice and flush. So what I'm gonna do next is take this piece and mount it to the heating surface, right? As you all see, it has some pre-drilled holes at the top and at the bottom, at all corners basically. And what I'm gonna do is I'm gonna take advantage of that and just use some drywall screws with some washers to actually just mount this. you know So the first thing that you want to do when actually doing this, make sure that your work is always flush, and by that it means that your sides are parallel and they are aligned, So when you clamp it down, don't clamp too hard. You might crack this fragile surface. So I'll make sure that it's square on all sides before I actually go ahead and actually fasten everything. So I think one clamp for this actually works. Yeah, it works well. Just make sure it doesn't move. And then we go ahead and flip it. That way you can see the holes on the bottom corners. And these are the holes that we're going to be using to actually drill through. So in this part, what I'm gonna be doing basically is I'm gonna be mounting these how do they call these things again? These are rails. These are things that you see in your refrigerators, the bottom doors, the freezers, or in your kitchen drawers. It's these are heavy duty gliders. So I'm gonna be using this and mounting it at the bottom, and very quickly it will become apparent why I'm actually doing this. Okay, just to break it to you, it's because I just want to be able to move it back and forth, uh, because it doesn't have any temperature control. So what I thought is if I could move it closer or further away from me, for depending on the thermal comfort, it's kind of convenient to actually do that, I thought. But we'll see once I actually get to use the whole thing. So you want to spray everything. This is Q30 that I'm using. It's an industrial lubricant. Works quite well. So what you want to do is spray it and then move the part back and forth. And once you can feel that it's moving and it's all smooth, you want to wipe it down. Not where it's actually going in between the moving parts, just on top. Otherwise, I'm just gonna be making everything else dirty. So now it's moving well, no friction. And then what I'm doing is I just turned it upside down, and I'm gonna be using the holes that are already pre-drilled on the rails basically. This makes my job so much easier. In fact, that's what they're meant for anyway. So um, I'm gonna go ahead and actually screw some uh, screws. Yeah, screw. So the first thing you want to do is make sure that your workpiece is flush and it's 90. So I'm gonna be mounting it about I'm gonna be mounting it about 10 centimeters away from the edges, making sure that it's flush, right? And once I've done that, I just wanna secure it with some screws, and then I'm gonna go and do the same thing on the other side. So I'm taking the middle holes. Just gonna go ahead and mark them, and be careful of the screws that you're gonna use. Make sure it's the flathead screws. Otherwise, if you have the rounded ones, what they're gonna do is that they're gonna distract the second rail, and then you're not gonna have that gliding motion. It's actually gonna block it. So make sure it's flathead screws. Again, you start off slow and then press it in. Again, double check if it's 90 degrees, and do the same thing. Just screw it down. Make sure that it's tight. Yeah, yeah, that works well. That works very well, and it's actually quite tight, and it's not something that's gonna break or fall off anytime. So I'm just gonna go ahead and repeat the process for the second glider. So now that we got them both working properly, as you can see, I think it's time to actually test this whole thing. So gonna take it down and see how it actually looks like. I'm not impressed with how it looks, but maybe it works better than it looks. Let's see. No, it's actually scratching the floor, and it's a bit wobbly, so I think I'm gonna have to do something to work around that. So yeah, I think let's add some wood to it. Then we can reinforce the bottom with some wooden pieces. And so yeah, we just went ahead and actually cut these two wooden pieces, and again make sure that they actually parallel and that they actually flush with the sides, right? And this you have to do before you put in any screws, guys. It's very important. Otherwise, it's just not gonna move as smoothly. So put it down, uh, get your measurements right, and then move it back and forth to see if you're satisfied with the movement, and then you can actually screw it down. Um, Mine is looking good there, so I'm gonna go ahead and actually uh, clamp it down with some screws. Do this for both sides, using again the same dry screws, flatheads. Yeah, I'm content with how this one works. So yeah, I think that will be it. So I'm gonna go ahead and strip some uh, copper cable. The same one that they use for AC. I'm not sure of the size, but I mean this is pretty familiar. I think everybody has seen this, right? So the same thing you can get in any extension cord or any appliances. And so what I'm doing is that I'm using some terminals to end off these wires because our load, which is the panel heater, makes use of this sort of connection. So this is why I'm actually using these. There's so many other different ways to actually terminate these wires. So I'm using that, and for connecting wires together, I like to use the ferrules. Uh, as you have seen in the parts list. So you're gonna start off with uh, putting the terminals to the wires and actually clamping this, or rather crimping them. So you do this, and every time you're done crimping, you want to pull it out to see if it's tight enough, if it's secure. Because if it doesn't, your wires just want to come loose, and that can cause a short. Yeah, as I said, you need to make sure that it's actually tight. Not sure if I'm using this correctly even, but whatever crimps this thing tightly, it's all good for me. So now we've come to the part where we're doing the spst. That's the single pole single throw switch. And the most important thing about the switch that you must note is that it's numbered from 1 to 3. And it's important that you get this right when you're doing all the wiring. But you don't have to memorize how this is done, because I have included a sketch, a detailed sketch, and a mini report that you can get access to if you need to get the technical specs of the switch. But really, you need to download it if you do not want to make any mistakes. Um, yeah, because I also struggle with this a bit. It seems kind of trivial until you're actually working with it. It kind of gives you some problems because it's not something I work with every day, but it's pretty simple to get it right if you're following the instructions. So please do check out that material, the support material that I provided. So one of the reasons that we're using these insulated terminals is because we don't want to use solder with this sort of work, because remember that we're using AC. It's a 400-watt panel, and these terminals can get hot. So when they do get hot, um, solder will actually melt. So using this is much safer. It's recommended. Don't try and solder these things together, because once all the current starts flowing there and these conductors starts to heat up, everything is just gonna come loose, and that is gonna be a huge disaster. So yeah, I would say just go for these ones. And besides, they make it easier for you to actually put the whole thing together. So as you will see in the way I put this together is that on pin number one, I actually have the live. Actually, this power, right? It's directed. It's connected directly to the power. And on pin 3, I've connected my neutral directly to pin 3. Those are first two connections that you're going to make, right? On the spst. As you can see, you have the live wire going directly to pin 1, and then the neutral going directly to pin 3. Also take note that I've added some extra wires on some of the terminals, and you will see later why. But please do make sure that you connect this the right way. So in this part of the video, I'm going to be showing you how to do the electronics of this circuit, which is basically the control circuit. And the most important thing to realize is that our load works with 220 volts AC, but our electronics works on 5 volts DC. So to get to that, we have to make use of a power supply, an AC to DC power supply. And in this case, we're using a normal cell phone charger, which gives out 5 volts as its output, 5-volt DC. And so to get started, I'm going to be connecting my devices using ribbon cables. Here I'm using 10 centimeter long female to female ribbon cables. And as you can see, I am starting with the relay. This is a Keys's relay. It's a single relay, and so it has a ground, 5 volts, and signal terminal. And the same goes for the PIR motion sensor. So first of all, I need to see that these wires are fitting properly, and then I'm gonna go ahead and make sure that I can see the polarity of the PIR sensor, because if I connect them wrong, it's gonna damage the circuit. So now I know where my ground is, where my 5 volt is, and where my signal is. And so basically how it works is that the PIR motion sensor, once it detects movement, it will give out a signal, a high signal, and meaning it's an output. And then that will be going to the signal of the relay, which is an input. So basically, by triggering the PIR motion sensor, we will be effectively triggering the relay to close in our case, because I'm connecting our load on the normally open. So every time that the sensor gets triggered, our relay actually is going to close our load, and that will actually connect our load. So that's how it works. You can connect it in what they call this normally open as well in certain cases, but for us it's going to be in the normally open situation. So now I have my power supply. As you can see, the red is the 5 volts and the white wire is the ground. So I'm just going to add some solder to it, and then I'm gonna take these wires and connect it to the entire circuit, the electronic part of the circuit rather. So what I'm gonna do basically is connect the 5 volts to the 5 volts of the circuit and the ground to the ground in such a way that it feeds power to both the relay and the PIR motion sensor. When you're soldering, be sure to make sure that these guys don't actually touch, because then it's a short circuit. Because these are very fine instruments to be working with. As you can see, the terminals are very close together. So um, make sure that you don't put on too much solder, otherwise the two are going to touch and that's going to create a short circuit. So just work slowly and accurately. And now it's time to connect the power line. And so the way I've connected it, as you can see, this power now is going to run through the relay and the motion sensor. As you can see, I have the entire circuit now connected. So this circuit as it is right now will be able to go from 220 AC to 5 volts DC. And so now what I'm doing is cutting some terminals. These are a bit of an overkill in terms of the amperes. It's about 32 amps, but the reason why I chose these is because of the size. They're actually the perfect size for me to connect to my 5 volt charger. As you can see, this allows me to connect a live and a neutral uh, conductor to it, as well as actually insulating that connection, so makes it easier for me to put together and remove. So now I'm gonna go ahead and connect a live and a neutral to these terminals, just to check whether our circuit is working correctly. And I'm gonna be listening to hear if the relay clicks uh, every time I activate the motion sensor. Once I know that everything here is well and working perfectly, then I can proceed with adding a load and all those other parts. I'm gonna go ahead and strap everything down with some tape just to keep everything in place, because these can be quite fragile. And again, I want to make it as compact as I can. So uh, using this tape is just the safest way to keep wires from moving, and breaking off. So uh, let me see what happens when I actually plug this in. And yes, I'm already hearing the first clicking sound of the relay. And so what I want to do is change these uh, on these terminals, these variable resistors. You can change the sensitivity and the time delay, and the information on how to see which is which is by going to the description, and you will see I've added a link there that describes each component in detail, so that you will know how to actually use it once it's connected. So I'm content with how this works. So the next thing to do is to just uh, put everything together and tighten it so that it can fit inside the enclosure, since we have limited space we're going to be working with. So our enclosure is kind of small, so I want to keep this as compact as possible. So I've made use of double-sided tape to put everything together. Double-sided tape is like the second best thing to hot glue, basically. As makers, we use this in almost anything. So always keep one, because you never know when you just might need it. And then we have our circuit is looking good and compact. So and it's ready to actually be tested with a load, which is exactly what I'm going to be doing next. So now that we're done with that, the next part we're going to move on to is finishing off the spst connection. And in this part, I'm going to be doing is connecting the relay, and or rather the electronic circuit, to the AC circuit. Basically, this is uh, the most important part, actually. Uh, this way I demonstrate how to actually put together two circuits that use different currents and voltages. And the way we do that is by, first of all, being able to take the 220 volts and stepping it down to 5 volts DC, and then being able to isolate these different voltages by making use of a relay. So if you look at the way I've connected this, you will find that pin 2, as I have made it brown intentionally, that is our hot wire. I'm going to go ahead now and connect it to the common of the relay. I'm going to connect that to the common wire and screw it down tightly, because what I want to achieve is that when this circuit is off, I want the when rather the switch is off, I want the electronic part to be off completely, and when it's switched on, only then should it be able to detect motion. And so I've taken that live to the common. And what I'm going to be doing is I'm going to have another wire, as you will see, on the relay, on the normally open, going to our load. So, but now I'm going to be doing is connecting the neutral. So remember now, because we have uh, the AC to DC converter now, we also need to feed it with AC voltage. So I'm going to be using these ferrules to connect that circuit to the AC. I know it sounds a bit confusing right now, but again, as I've added timelines to the video, those timelines correspond exactly to the mini report that I have put together. So every time you go to this part, you can always relate it to another part in the mini report. Let's say it's a PDF that gives you everything in detail. So the parts that I'm clamping down now, because as you can see, I'm using the ferrules, is because now I'm officially taking them to the uh, AC to DC power supply. So I don't want them to slip out. I want them to be nice and thick so that it can actually grip. Otherwise, if you just do it as uh, a simple wire, it's just gonna slip out. You never know. I've experienced that before. So just to make sure that I hold it in place, I just increase the size, and that makes it more reliable. So I'm gonna clamp that down tightly and do the same with the um, live. Realize that the neutral is connected directly to the neutral that's going to be coming off of the wall socket, right? Everything is just neutral, does not matter. The one thing that we continuously breaking is the hot wire, meaning the live wire. That is the wire that I've broken, first of all, on the switch. As you'll see, I broke it by okay, I've started breaking it at the spst, so meaning it's not connected between pin 1 and 2, right? And then again, I've broken this hot wire in between my normally open and the load, so the neutral stays connected throughout. I don't need to break it. It can stay as it is. So the live wire is what I'm gonna be switching on and off and stuff like that. And again, you can look at the resources if it sounds a bit confusing. So as you can see, from pin 2, I'm powering the um 5-volt charger, and from that very same line, I have connected the live again to the normally open of the relay. Make sure, not the normally open, but rather the common. Sorry, my mistake. The common. And on the normally open, that's where you're gonna connect the wire that goes to the load. So there, have it nice and tight. So yeah, make sure that it's nice and tight. As long as it can keep spinning, just make sure to hold it down and then pull it out to see. Yep, it's looking good. So now wait, let's double check again. Let's double check the circuit before we continue. Um, so we have the motion sensor. Okay, wait, it's the switch. When you switch it on, what will happen is that the connections between 1 and 2 will become in contact, and that will then feed power to our um, 5-volt charger and the common of our relay. The other part of the live will be going to the our load. So what this means is that if when this switch is off, this circuit again also is going to be off. It's going to be totally switched off, right? And when it's on, you're going to be switching on the electronic circuit and the load, depending on whether you can detect motion or not. So this is how we're following the circuit, and it's the same as what you will see in the report. Yeah, there you can take your time to actually see these connections. I've made it as clear as possible. So like I said, we don't need this wire, so I'm gonna tape it down, because remember what I said. If I was to connect these two directly to my load, then the heater would always be on, if you think about it, because then it will be receiving neutral and live from my AC, right? So we don't need this wire. The way I'm gonna connect my live wire to the load is actually through the relay. So um, yeah, that's a mistake that I made, but easily rectifiable. Just gonna close it down with some electrical tape. So these things happen, guys. These things happen. That's what I'm saying. You need to pay attention and continuously double check your circuit. Follow your circuit, make sense of it, throw it down, and yeah. See now, yes, this will actually work. Yes, this one's gonna work. So, I'm content. So let's. Yeah, I think yeah, we can move along now and connect the rest of the circuit. Not really much left to it now. I have the 5 volts. There's my normally open. That's gonna be triggered by the um, PRR motion sensor. So once I'm done connecting this, I think now we can use a real load to actually test the circuit. Again, we're gonna do the same thing, just screw it down, make sure that it's nice and tight. So now this is the wire that actually is gonna go to the load and not the one that I just taped. Yes, I think there was a mistake that I made there. So yeah, it's looking good. Now trace it one more time. Let's see. And yeah, I think it's looking good. It makes sense. So um as you can see there, we have two wires on pin 2. One that goes to the common and normally open, and as you can see, when the power closes, those two wires are actually gonna be in contact, and so the circuit is gonna be closed. Everything is looking good. So yeah, let's go ahead and actually connect the load, man. Let's go and connect the load and see if this thing works, man. Yeah. So the red light actually shows that this actually it's working perfectly. As you can see, switching on and off, we get in the switch to switch on its indicator lamp, showing that actually it's receiving power there. There are no shorts. If there were, trust me, we would know by now. It would have tripped the mains or something like that. And again, I can still hear the clicking sound from the relay, so I know it's working. But in order to set the delays, I'm gonna have to use a real load. Um, so everything looks good. Um, so we have the PIR motion sensor installed. I just use some hot glue for this, right? And the circuit is looking compact and neat. Uh, there is no danger of any terminals short circuiting. Everything is nicely insulated, and yes, I trust that this will work well. So let's go ahead and connect a load. For this test, I'm going to be using an AC lamp, right? So I'm going to use this as my output before I actually take it to the real thing. And so as you can see, um, once this circuit has been put together in this way, it can be used pretty much for any AC load, right? Whether you want to control your lights, or whether you want to control your heaters, or whatever you feel, man, you can connect this thing to a kettle or whatever. It will be, automatically switched on if it senses any movement, right? So it's not to say this just for the heater, and this is how I'm actually demonstrating. Like if you actually connect this, you will see you should be able to control this load. via the electronic circuit. So even for these tests, you're still gonna need to insulate your conductors, because if you go ahead and switch this thing on and these two parts actually touch, it's gonna create a short circuit. So you have to be protected at all times. For your own safety, never work on open wires. Okay, so there is our load. It has went on. This is by default. If I switch off the whole thing, the whole power goes off. There it goes again. So, like I said, the way the circuit works is that if we switch this on, it should be able to supply power to the load and to the electronic circuit. Um, so what I'm going to be doing, and again, as you can see, I'm using a screwdriver that has a plastic handle and also a plastic covering all the way through, so that even if I was to put it through the terminals and it actually touched two of those, it won't actually create a short. So what I'm doing now is just adjusting the time and sensitivity there. Um, so I've decreased the sensitivity and the time so that you can have a proper demonstration of how it switches on and off as I move. Okay, that it has a bit of a lag, but it's something that we can fix. There again, still not 100%. Um, okay, let's see again. There is still a bit of a lag. As you can see, the time delay is very short, like this, like a second. So even if this was a heater, it will be on for like 1 second and switch off, which really wouldn't make sense, right? So you would have to increase the time that it actually stays on. Okay, there it's working much better. Um, so yeah, go ahead and play around with these. Like I said, again, you will see how to change these on the PDF that I've attached on the description, yes, of the video. So I've increased the time here, and as you can see now, the bulb actually stays on for much longer, right? This would be more practical if we had a light that uses a motion sensor. You want it to be on for like 5 or 9 minutes. I think the most that this thing can go on for is like 9 minutes. So that is more practical. But again, it will depend on the application that you use it for, right? As you can see, it is still going on, and so I'm not gonna go ahead and make you wait for like 5 minutes. Just to demonstrate that you can switch the timing and the sensitivity. So now that we're done with this, let's go ahead and connect the real load to this thing. So we've come to the part where everything is all sorted. We have the panel and we have the circuit already. It's now time to actually put these things together and see how it works. So the first thing that I'll do is just slip the whole thing through the hole, and first of all connect the load, which is the heater, as you can see. And again, this is why we were using these terminal connectors, because of the load. As you can see, it makes use of these connectors, which are easy to slip on and off. So now that we have our load connected, we just want to go ahead and push the entire circuit through and make sure that it does not obstruct any other wires. So the important thing to do here is to make sure that none of the wires are actually touching, when you uh, sort of fasten the whole thing together, right? Because there's not much space here, and this whole thing still needs to go into a enclosure. Um, for putting this together, I'm just going to be using hot glue because I couldn't find another option. So, and at this top corner, it really does not heat up, so the hot glue will not be affected by the heat from the actual panel because it actually heats up more towards the middle of the panel. So now that all that is done, it's time now to install the entire circuit into the enclosure. Um, the enclosure is it's not so spacious, so it's gonna be a bit of a struggle getting it in. Especially since you don't want anything to be sort of shorting and stuff like that. So be sure when you do this that you give it enough space in the enclosure. Make sure that none of the wires are touching or something like that. Or also ensure that all the wires to the electronics are still intact because I didn't glue those together. I don't like doing that. So just make sure that they're still intact. And once you have everything aligned, just use a screw on the top corner to just hold the thing in place. This way it's easier to remove later on if you want to remove it for whatever reason. Maybe you adding some improvements to it. Make sure that it's nice and tight and it doesn't move. So it's looking good, it's going on, nothing is shorting. And yeah, I think this is the end. As you can see, switching it on turns on the red light, and from where I stand, I can hear the clicking sound of the relay. So now it's time to test it in its true setting. As you can see, it goes on, and I can move it back and forth with my leg for thermal comfort, and that for me is a good project. So I have just wrapped this one up. If you have watched up until now, thank you guys. And if you want to try this, just go ahead and do it for any other project. So guys, there you have it. Please like, subscribe, and leave some comments. I would really love to hear from you guys. What you think. Where I should improve, the type of projects maybe that you guys want me to do. But yeah, as I said, man, it's all about taking you guys from the desktop into the real world, man. We really building like projects that can even become commercial, and that's what I'm aiming for with the whole channel, is to build projects that actually like can start selling, online and stuff like that. So just keep following and subscribe. You'll get some of my latest work. I'm really gonna be pushing for a lot of things. And again, thank you so much for watching. Get in contact. I'll be hearing from you. Thank you.